Welcome to myprojectbazaar.com. Our project title is Diversity Backpressure Scheduling and Routing with Mutual Information Accumulation in Wireless Ad Hoc Networks. Abstract. We suggest and analyze algorithm for routing in multi-hop wireless ad hoc networks that exploit mutual information accumulation as the physical layer transmission scheme and are capable of routing multiple packet streams when only the average channel state information is present and the only locally. The proposed algorithm or the modification of the diversity backpressure algorithm under which the packet whose commodity has the largest backpressure metric is chosen to be transmitted and is forwarded through the link which is the largest differential backlog, that is Q length, in contrast to traditional div bar. Each receiving node stores and accumulates the partially received packets in the separate partially packet queue, thus increasing the probability of successful reception during a later possible retransmission. We present two variants of the algorithm: div bar renewal mutual information accumulation RMIA, under which all the receiving nodes clear the received partial information of the packet once or more receiving nodes firstly decode the packet, and div bar full mutual information accumulation, that is FMIA, under which all the receiving nodes retain the partial information of the packet network capacity region with the RMA retransmission scheme and prove that it is strictly transmission scheme that is used by the traditional div bar. We also propose that div bar RMIA is throughput optional among the policy with RMIA, that is, it achieves the network capacity region with RMIA, which in turn demonstrates the div bar RMIA outperforms the traditional div bar with respect to the achievable throughput. So, in our proposed system, we prove that our div bar FMIA performs at least as well as div bar RMIA with respect to the throughput. Let us see the output of our project. First, in our wireless ad hoc network, we create networks. Our network contains 40 number of nodes. Then we have to sense the range among our network. So our network is 600 cross 600 area size. Firstly, we have to implement our proposed scheme called RMIA process. RMIA is nothing but renewable mutual information accumulation. In this concept, we have to get partially accumulated information, that is the source node which sends the packets to the neighbor nodes. So now we have to implement this RMA concept which accumulate the partial information. Then afterwards we have to send these partially collected information to the FMIA process. So FMIA process receive partially information packets and validate that packet. If the validation is done, data transmission is successive data transmission is done, and backlogs are stored. So backlogs are nothing but the queue length which calculated by that traffic TCP or CPR traffic. If the validation is not done, means first the packets are sent to the RMIA process, then afterwards it will processed in FMIA, and the packets are sent to data transmission as well. Let us see the output of our project. First, open the VMware workstation. In that, click on this terminal window for running our process. So now go to that our folder. For that we have to change directory to our coding folder. Then this is the syntax for running our TCL file. This is the main file. So first run this file ns space main.tcl. So when we type this, means it will generate our packet size it will generate our packet size and lambda mbps, there is a throughput mbps, and the interval rate for our cpr traffic, and average queue length. There is we calculate the queue length for storing the backlogs. That file is stored in avgql dot output file. So this will generate one file called a NAM window. So this is our output window. So our network contains 40 number of nodes. We connect source and destination. Node of 10 acts as a source and the node of 38 is act as a destination. We have to, when we click on this first play forward means it will process our network. So now all the queue length are set, and accordingly wireless ad hoc networks are in mobility. Mobility is nothing but movement. All the nodes are now in movement. So now the queue length is calculated and is stored in backlog. That is stored in this code folder. So this code folder which contains avgql.txt file. So this is our queue length file which stores all the information about the received partially accumulated informations as well the fully accumulated information. RMIA and FMIA process. This is our queue length. Now when the process is in 10 seconds, it will start the transmission. So now the packets are transmitted to from source to destination node. So the beacon, this is nothing but these circles are denoted as beacons. So the source and destination node have the beacon because these two nodes are transmitted each other. So now the information is transmitted between the source and the destination. When we click on this means it will denote our process traffic. That is, we use TCP and 1060 bytes are sent from source to destination at the second of 12.33. So for running our evaluation graph, we have to click on this terminal window once again and type awk space -f space thr.awk space out.tr. This out.tr is our trace file which trace all the information about our wireless ad hoc network process, and when we click on type on this means it will generate one file called thr.xg. For running our graph, type xgraph space thr.xg. It will generate our throughput file. So we have to achieve this much of throughput in our project. Thank you for watching.